Okay. For ohmic conductor, 他们 obeys Ohm's law， 所以它的 graph 会是指 VI， okay， 或者 IV。 Now the second type of component, okay, so okay, this one I write it here. This one is for fixed resistors. Fixed resistors with fixed at constant temperature. Okay, they always Ohm's law. Now the second one is we are looking at bulb, filament bulb. Filament bulb 有一点不同啊 ，OK， filament bulb 是什么来的？就是好像普通那种灯泡啊，可是它的灯是从那个里面的那个 wire 啊，我们叫它 filament 呢。OK， 还是这样子的。This is the bulb. This is how it looks. Inside you got the filament wire, usually made of tungsten. Okay, tungsten it can withstand very very hot, very high temperature. So electricity passes through the wire, and this wire is heated. This is, we call it the filament. Okay, the coil of wire, we call it the filament. So when it heats up, it will glow, and it will produce light. Okay, that's how the bulb gets its light from. Okay, so this is filament bulb. Okay, so for filament bulb 它的 IV graph 是不同的。你不会拿到 straight line 的，因为 filament bulb 它不 obey Ohm's law 的。Okay, so the graph looks like this. Okay, let me draw it here. Let's say we are doing IV graph. Okay, so the graph will be curving like this. Why this curve like this? You see, if I calculate the gradient is increasing or decreasing. This one. The gradient is initially it is constant. You can see for a small voltage, the resistance is constant here. You get a proportional line here, just for small voltage. Okay, so here, after this, it starts to curve like flatten. So if you take the gradient, if you measure the gradient at this point and at this point, actually the gradient is decreasing because it's going flat and flat, right? Okay, it flattens out. So the gradient is decreasing. Now gradient is decreasing, what does it mean? 你的这个 graph 是什么 graph? I against V, 对吗? I against V 的 gradient 就是你的 1 over resistance. Okay, again, this is very important. VI 你的 gradient 是等于 resistance. IV graph 你的 gradient 是等于 1 over resistance. So if the gradient decreases, which means that because it's an inverse relationship, right? So which means that the resistance increases. This graph is telling you that the resistance is increasing. Okay, that's why when you increase the voltage, the current only rises a bit. Because in this area where it flattens, the current only increases a bit compared to initially this one, it rises a lot. Okay, so you can look like this. The way you see it is like this. I can take 1 point, this one. Oops, wait. Okay, I take this point. This is V. I take the same length. This is also V. And I draw the line here to the y-axis. For this amount of V, what is the current increase? This one. I1 lah, call it I1, V1, I1. For this amount of V increase, what is the increase of I? Only this small, tiny bit, I2. Okay, so this is V1 because they have the same value. The same increase in V, the I only increase a bit. So meaning that the resistance is already high here. Okay, so for filament bulb, we can conclude that the resistance is increasing. It is not constant, not like the ohmic conductor, not like fixed resistor. Okay, but we are not talking about the temperature yet, because even at the same temperature, the same room, the filament bulk, the resistance will increase. Okay, so why this one will increase? Because when you increase the voltage, okay, as the voltage increase, what happens to the current? Larger current flows through, right? Larger current flows through, and the larger current can heat up the lamp filament wire. Okay, so what happened? The filament, I said just now, I said it's made of tungsten, right? Tungsten is a metal. When metal heats up, what happened? Metal at higher temperature, just like the collision that I tell you just now. When metal heats up, the atom vibrate faster, and there are more collisions blocking the electron flow. So this one, metal, I can say that metal at higher temperature have higher R. Okay, have higher R. So why? Then you need to be explained. You need to be able to explain this. Okay, the collision of particles, that all that. Okay. So conclusion: the increase in the current leads to greater resistance. Causing the curve to flatten out. What curve? The VI graph curve, okay? To flatten out when higher voltage try to drive higher current. This one. Okay, so that explains the VI graph of the filament bulk. Okay, so next we are going to combine everything together. Okay, we learn about power, energy, and the calculation of series parallel. Let's look at everything like combined in one circuit if we want to calculate everything. Okay, first we calculate the current flowing in the circuit. Okay, so this should be no problem. V equals to IR. Current total, voltage total over effective. Okay, so first we find our effective. Which one do we combine first? We start from the back, right? We start from the back of the circuit. The battery is the front, so we go from the back here. We combine these two first, R3 and R4. So I just add it up. They are in series, okay? So how do you know they are in series? One way to help you is you look at the current flow. Okay, current flow out from here, down. At this junction, they separate. But the same current is flowing in this branch, R3 and R4. So they are in series. 3加3 OK 6 so combine 了这个两个变6然后我又 combine 跟 R2 所以我有1 over R 等于1 over 3加1 over 6 so 3 over 6 31326 1 over R is equals to 2 ohm. Okay, so 2 ohm and then I combine again with R1. Combine with R1, I get 5 ohm as the effective resistance. Okay, so IT 等于6除以5 1.2 ampere total current. Okay, so current coming out from the battery 1.2 ampere. Okay, now I want to find the voltage across each resistor. I mean each bulb. Okay, these are all bulb. Voltage across each bulb. Okay, so let's find out the V1 first. Okay, our diagram, let me redraw it so that we can see clearly. This one, we have this, and this one we combine until here, right? Combine until here. So this one I will call R234. R234 is all these three combined is equals to 2 ohm. And this is R1, 3 ohm. Okay, 6 volt. 1.2 ampere coming out from the battery passes through this one and this one. Find the voltage across R1. Okay, then I find V1. V1 就是等于 I1 R1。然后 I 是一样的嘛，这边 1.2 所以 V1 就是等于 1.2 乘以3等于 2 times 3. Okay, so equals to 3.6 volt. Okay, V1 是 3.6 volt. 这样子 V234 呢？因为这个是 series circuit 哦，所以我可以直接用6减掉 3.6。所以 6 minus 3.6, I get 2.4. This is 2.4 volt. Okay, now 2.4. Now 这里哦，我要找 V2, V3, V4。可是我知道这里的 potential difference 是 2.4， 这个我也是可以讲是在这个 corner 这边的。我拿这个 corner 跟这个 corner， 如果你拿 corner 会比较容易看的。所以这里跟这里也是 2.4 吗？也是一样的，因为我没有经过一个 resistor. As long as it is in the same, it is only the same resistor inside the 2 points. Okay, so this is also 2.4. Now these 2 points in the first diagram, it is these 2 points, A, B. Okay, 这个两个点，这个两个 point A, B， 我知道它的 potential difference 是 2.4。然后如果你看这个 circuit 哦，我有两个 branch， 这个是第一个 branch between A, B， 然后第二个 branch 就是后面这一个也是 between A, B 的 branch， 意思是说他们两个的 voltage 都是 一样，因为 voltage between the same point, no matter how many branch you have between that point, all the branches they have the same voltage. Okay, so 这个是2.4 2.4 volt, and the back one also 2.4 volt. Okay, so R2 you already know lah. R2 is 2.4 volt. Okay, not R2 is V2. So V2 equals to 2.4 volt. Now, how about V3 and V4? I know V3 and V4, this branch is 2.4 volt. So I have to calculate the current first. I want to know how much current is flowing in this last branch there, I. Okay, so how much current is entering here? I can use V equals to IR, but the V, I'm going to take the V only across this branch, AB. It's 2.4 equals to I. Now, resistance 只是 R3 跟 R4 罢了咯，3跟3 6. Okay, so from here, I equals to 2.4 divided by 6, you get 0.4 ampere. Okay, so 0.4 ampere is coming down here. Then I know how much current is going inside here. This current is 1.2 minus 0.4. You get 0.8 ampere. Okay, now 0.4 ampere 是同样的，经过3跟4是一样啊 ，current 不会减少的。OK， 减少的那个是 voltage， 那个 drop 是 voltage， 所以一样经过这个两个。所以我可以找它的 voltage V3 等于 I3 R3。OK， 0.4乘以3， 1.2 volt， 然后 V4 等于 0.4乘以3， 也是 1.2 volt， 所以总共是 2.4。找完 V1 2 3 4了，你就要找 I1 2 3 4。OK， so I 其实你不用找了嘛，你找 V 的时候你都已经找完了。I 是哪里 ？I 就是这个 1.2 咯，出来 battery 出来到这边 ，I 是 1.2 ampere。I2 呢 0.8 咯 ，0.8 ampere。I3 跟 I4 是一样的 ，I3 等于 I4 等于 0.4 ampere。OK， so 找完了这边全部，现在我们要找 power。OK，power across each resistor。Across each resistor. Okay, so P1 就是 I1 V1. Okay, general power equation. 你可以用那个什么power 有几个 equation 对吗？你有什么 V I square R P equals to V square over R 这种都没有问题的。可是since 我已经知道 IV 了，我就直接用 IV 了。Okay, so IV I1 V1 1.2乘以3.6等于 power 是4.32 watt。P2 I2 V2 0.8乘以 2.4 1.92 watt， 然后 P3 0.4乘以 1.2， 就是 0.48。 And last one is I4 V4 equals to 0.4 times 1.2， 也是 0.48。过后我也是要找 power from the battery。 OK， power from the battery P 也是等于 IV， 可是这个是 battery 的，等于 1.2乘以6，拿到什么 7.2 watt。 OK， 7.2 watt。 Now power 是 energy over time 对吗 ？energy over time， so 它是 how much energy in 1 second。所以如果我讲 power battery 的 power 是7.2，代表什么意思？代表是每一秒它在给着7.2 joule energy，OK？它在给着7.2 joule energy。这一个 P1 是那个 bulb 的 power，bulb 是发亮，所以它需要 consume energy。OK， 所以 bulb 不是 supply power，battery supply power or supply energy，bulb consume energy， 所以这个它 consume 多少 4.32 瓦，意思说是它 consume 4.32 joule 每一秒 in 1 second。bulb number 2， 它 consume 1.92 joule 每一秒 ，OK， 这个它 consume 0.48 joule 每一秒。这个也是每一秒它 consume 0.48 joule。OK，battery 每一秒 supply 7.2，这种 bulb 全部每一秒 consume 这样多。你看哦，在1秒里面哦，总共那个 bulb 用多少 energy？ 把它全部加起来 ，4.32 加 1.92 加 0.48 再加 0.48， 你拿到 total 是 7.2。OK，so 在1秒里面 ，total 的 energy consumption 是 7.2 joule， 刚刚好我的 battery 也是在每一秒它 supply 7.2 joule， 所以这个跟你讲什么？这个跟你讲 energy is conserved in the electric circuit. Conservation of energy， 你 supply 这样多的 energy， 这样多的 energy 是 has to go somewhere. It cannot be different. It cannot disappear suddenly. It cannot be extra. It has to be the same. How much you put in, how much you get out of it. Okay, so this shows the conservation of energy, and also the power also is conserved. Power in the circuit is conserved. That's why you get the same here. Okay, now 这种 V 你找到的这种 V 是什么来的？是 EMF 吗？不是 EMF 啊。这个6 volt 啊 ，battery 这边是 EMF 吗？不是 EMF。这个是什么？这个是 terminal potential difference。Okay, terminal potential difference. So 6 volt， 因为这个 circuit 是 closed circuit 嘛，对不对 ？So the potential difference across the battery in a closed circuit is actually the terminal potential difference. So 如果我讲它的 voltage drop 是 let's say 是 0.8 volt， 这样它的 EMF 是多少？如果 voltage drop 是 0.8 volt， 意思是说它真正的 voltage 其实是 6.8 volt。这个 6.8 volt 是如果你这个 circuit 你是 open circuit 的话，当它没有 current flow 在这个 circuit 的话，你会看到它的 reading across 那个 battery 是 6.8 volt。OK， 假设讲如果 voltage drop 是 0.8 啦 ，OK 啊 ，voltage drop 是 0.8， 也就是说它的 EMF 啊，因为 EMF 是等于 potential terminal potential difference 加 voltage drop 嘛，对不对 ？So 6 plus 0.8 you get 6.8。所以考试啊或者那种 test 啊，他们会问你，如果我开这个的话，这个是 open circuit 的话，这样它的 reading 会 show 什么 ？Then you have to know it is actually showing the EMF in an open circuit. So this would show 6.8 volt. Okay. Now, if the question asks you to calculate, okay, what is the internal resistance then? What is the internal resistance in the battery that is not shown here? Then you take the voltage drop. Voltage drop 就是等于我的 I， 然后我的小 r 对吗？也是 V 等于 IR 吗？只是小 r， 这个是 internal resistance. So voltage drop is 0.8 equals to the current is 1.2. We use the same current as the circuit, okay, as the circuit. So 1.2 R. R equals to 0.8 divided by 1.2 equals to 0.67 ohm. 0.67 ohm is the internal resistance. 明白吗 ？OK， 所、以如果我要画我的 diagram， 我要 show 那个 internal resistance 的话，这样画，这样子咯，这样子画。OK，battery， and then here we got the internal resistance. We got draw a box like this. The rest is the same lah. Bulb like this, bulb like this, and then got two bulb here. Okay, I just extend this one. So this one is 0.67 ohm. 0.67 ohm. In a closed circuit, we measured from here to here. Closed circuit is showing terminal potential difference, so it's 6 volt. In an open circuit, this will show 6.8. Okay, so this is internal resistance and EMF. Now, if the question, again, the question asks you, which bulb is the brightest? Okay, which bulb is the brightest? The answer is, you look for the one that has the highest power. Okay, brightness 就是等于 power consume. 你 consume 越多 power, 你就越 bright. Okay, 我们不可以只是单单看 current, 因为 voltage 也是会影响。你要看 current 跟 voltage 一起，所以那个是 power, 因为 P 等于 IV. Okay, so which one is the brightest? 0. This one, right? So 4.32 is the highest power. So P1, bulb number 1, this first bulb is the brightest. Which one is the dimmest? The dimmest is the lowest power, so it is P3 and P4. These two, they are the dimmest, and they have the same brightness. Here. Okay, so can you tell which one is the brightest, which one is the dimmest without calculating? Yes, you can see in terms of the current movement. Bulb 1, current coming out from here, passes through the first bulb. At the junction, the current split. So the first bulb it gets the most current. Okay, it gets the most current, and also it gets the most voltage. Okay, so here at point A, this junction, point A and point B, what is the resistance here? The resistance of a parallel circuit, if you remember from the last lesson, the resistance of a parallel circuit is actually very small. The more branches you add, the smaller the resistance of that circuit. Okay, so if you want to calculate the effective resistance between AB, 就是这个三个 bulb 加起来 okay, R2, R3, R4, the effective resistance you calculate, it is very small. It is smaller than R1. It will be smaller than R1. Okay, we got it right. 2, right? 刚刚我们算到了吗？这三个 bulb 加起来是2，小过 R1。你再加多一个 branch 在后面，加多一个 bulb 这边，加多几个 branch 啦，它会越来越小，小过2，可能1.5又1，然后0点多，越来越小。Okay, 因为 between junction AB, parallel circuit, more branches, the resistance decreases. So if the resistance between AB is small, it means that the voltage is small. Okay, it means that the voltage is small. So what happens? So what does it mean? Meaning that R1 will be the brightest because not only it gets the full current from the battery, its voltage is also larger. Okay, its voltage is also larger. You measure the potential difference here. This potential difference is bigger than this potential difference here. What is our potential difference? Oh, 我擦掉了，我擦掉我的 potential difference. Okay, so what is the potential difference between R1? We can, it's 3.6, right? 3.6. 这里刚刚我们算到是 R1 的 potential difference 是3.6嘛，然后V234的 potential difference 是2.4，对吗？这是2.4，后面这个 branch 也是2.4，所以这个是3.6。所以第一个 bulb 不单指它的 current 比较大，它的 voltage 也是比较大，所以你可以知道它是 brightest. It is the brightest. Yes. Okay. So yeah, remember that one. In a series, in a series circuit, 你加越来越多 bulb， 它的 brightness 会减少，因为你的 resistance 整个 effective resistance 越来越大。In a parallel circuit, 你加越来越多 bulb, okay, you add more bulb, the brightness will be the same. Okay, the brightness will be the same. No matter how many branches, no matter how many bulb you add, it will be the same. Same brightness, does not decrease. Okay, why? Because the resistance will not increase. The resistance actually become lower and lower and lower. Okay. Okay, so that is a wrap for electricity. And the rest is just practice. Okay, practice, practice, and practice. You do more than you know how to answer the questions. Okay, so I will send you a few practice, and we take the time to do some exercises. If you have any questions, you can always ask me in the chat. Okay, give me a few seconds, a few minutes. I'm sending the exercise.